Hello, my friend. Welcome to a journey that spans billions of years through cosmic forces and time itself. The universe is filled with wonder, complexity, and quiet, unrelenting forces. Every day, we look to the stars, marveling at their brightness, but we often overlook what they truly represent. Tonight, we unravel the mysteries of the universe's ultimate fate and explore why everything, from the smallest atom to the largest galaxy, is turning into iron, and what this means for the stars, the universe, and our place in it. In the beginning, the universe was a vast expanse of gas and dust. It was the perfect stage for the birth of stars, those brilliant, fiery spheres that light up the night sky. These stars, burning bright with the energy of nuclear fusion, are the very heart of the universe. They provide the elements that make up everything we know: life, planets, and even our own existence. But what happens when they die? And how does this process lead to the creation of iron? Stars are born from vast clouds of gas and dust that collapse under their own gravity. As they collapse, the temperature and pressure rise, eventually triggering nuclear fusion at the core. The process begins with hydrogen, the lightest element, fusing into helium. This is what powers stars for millions to billions of years. But the end of a star's life is where the real mystery lies. As stars burn, they fuse hydrogen into helium, and then, as the star ages, they begin to fuse heavier elements: carbon, oxygen, and so on. The process continues, with the star creating elements like silicon and iron. But here's where things get interesting. When a star's core reaches iron, the game changes. Iron is the ultimate creation of nuclear fusion. When a star's core is mostly iron, it cannot generate the energy needed to sustain its fusion. Iron does not release energy when fused. In fact, it consumes it. This is the moment when a star can no longer sustain itself, and it faces its inevitable collapse. So, why is iron the breaking point for stars? To understand this, we must dive into the physics of nuclear fusion. Stars are powered by fusion reactions, when smaller atoms combine to form heavier ones, releasing energy. But when it comes to iron, the process reverses. No energy is released, and in fact, energy is needed to fuse iron. At this point, the star can no longer support itself. Once the core of a star reaches iron, the outer layers of the star begin to collapse under the immense gravity. The core contracts and temperatures rise to unimaginable levels. This collapse triggers a massive explosion, a supernova. In a supernova, the star sheds its outer layers into space, leaving behind a dense core. The explosion releases incredible amounts of energy, creating new, heavier elements and flinging them into the cosmos. In this violent, spectacular event, iron is not just the end, it's the beginning of something new. The elements created during a supernova, including iron, are spread across the universe, enriching the interstellar medium. These elements form new stars, planets, and eventually, life. It's fascinating to think that the very iron in our blood, the iron in the rocks beneath our feet, and the iron in the cores of planets like Earth all come from the dying moments of stars that exploded billions of years ago. The iron star era is the next phase in the evolution of the universe. As stars burn out and the remnants of these stellar bodies, white dwarfs, neutron stars, and black holes dominate the sky, the universe will be left with the elements created in those final stages of stellar evolution. Iron, having been created in abundance, will be the fundamental building block of these new cosmic objects. As the universe ages, fewer new stars will form. The cosmic fuel, hydrogen and helium, will be used up, leaving only the dead remnants of stars. Iron will be the predominant element in these objects, giving the universe a colder, darker, and quieter tone. The white dwarfs, remnants of low to medium mass stars, will be the first to burn out. These dense, Earth-sized stars will slowly cool and fade into obscurity. Meanwhile, the black holes, the densest and most mysterious objects in the universe, will continue to dominate the cosmic landscape. But the truly fascinating part of the iron star era is that the universe will no longer be as we know it. The stars we see today, bright and energetic, will be replaced by cold remnants. The glow of the stars will dim as the universe continues to expand and cool. Without the birth of new stars, the universe will become a quiet place. The light we see today will fade, and the galaxies will slowly drift apart. What was once a vibrant, energetic place will become a still, dim cosmos, filled with iron-rich remnants of what came before. While this might sound bleak, there is a strange beauty in it. The universe, after all, is not static. It changes, it evolves. From the creation of the first hydrogen atoms to the formation of iron in the hearts of dying stars, the universe's story is a constant cycle of life, death, and rebirth. The Iron Star era is a long way off, but it is coming. Over billions of years, stars will continue to burn out, and the remnants of their energy will slowly leak away into the void. But even in this quiet period, the universe will continue to move forward. The remnants of iron in the core of black holes, neutron stars, and white dwarfs will serve as the foundation for future cosmic events. And just as stars created iron through the process of fusion, so too will future generations of cosmic objects, black holes, neutron stars, and even the mysterious dark matter, be sculpted by the very elements that were forged in the hearts of those first stars. Perhaps, one day in the distant future, even the black holes will fade. The universe will enter its final phase, the dark era, where nothing remains but the cold traces of what was once vibrant. But as with all things in the cosmos, even this too will eventually evolve, giving rise to something new. As we end our journey through time and space, we reflect on the incredible story the universe has told us. A story that began with a bang and continues with a slow, steady rhythm. Even in the Iron Star era, there is beauty in the quiet, a peace that only comes from the slow, inevitable dance of the cosmos. Until then, my friend, rest in the knowledge that you are part of this grand story, this cosmic masterpiece, written in stardust and iron. The transformation into the Iron Star era marks a pivotal moment in the life cycle of the universe. Stars, those brilliant sources of light and energy, are the lifeblood of galaxies. They are the engines that drive the creation of the elements, nurturing the formation of planets, life, and even the very building blocks that make up the cosmos. But in the absence of new stars, what happens to the galaxy? What will become of these stellar remnants in the coming era? As we look ahead, the universe will enter a time when star formation becomes an increasingly rare phenomenon. With iron being the final product of stellar evolution, the resources necessary to fuel new stars will become scarcer. As hydrogen, the fuel for the stars, becomes less abundant, the birth of new stars will slow, and the galaxy will transition into a quieter phase. The golden age of star formation will have passed. The remaining hydrogen gas in the universe will continue to thin, leaving behind a cold, diffuse matter that will not form new stars. Instead, the remnants of older stars, white dwarfs, neutron stars, and black holes will dominate the galactic landscape. These objects will become the new focal points, their iron-rich cores serving as the final stage in the cycle of stellar evolution. Though star formation will eventually grind to a halt, there are still remnants that will play a key role in shaping the fate of the universe. White dwarfs, those dense, Earth-sized remnants of low and medium-mass stars, will slowly cool over the course of billions of years, eventually becoming cold, dark objects known as black dwarfs. While they may no longer shine, they will still exert a subtle influence on the surrounding space. Neutron stars, on the other hand, will retain their intense density and gravitational pull. These objects are remnants of more massive stars, and they will continue to serve as powerful anchors in the galaxy. Their existence will become increasingly isolated as the expansion of the universe causes galaxies to drift apart. The once vibrant, bustling activity of star-forming regions will be replaced by the slow, steady motion of these cosmic relics. The black holes, those enigmatic, invisible giants, will be the final kings of the cosmos. Their gravitational pull will continue to dominate their surroundings, and as the universe expands and cools, they will slowly accrete matter from their surroundings. However, even these behemoths will eventually succumb to the inevitable heat death of the universe when all matter has been drawn into their singularities. As the universe enters the iron star era, one crucial force will remain largely unchanged: dark matter. Though invisible to us, dark matter makes up about 27% of the universe's mass. Unlike ordinary matter, dark matter does not interact with light or electromagnetic radiation, but it exerts a gravitational influence on galaxies and clusters of galaxies. Dark matter plays a key role in the universe's evolution. Even as stars and galaxies evolve and fade, dark matter will continue to hold the structure of the universe together. It will serve as the invisible scaffolding, maintaining the cosmic architecture, even as the visible universe slowly burns out. While dark matter remains largely constant, there is another force at work: the mysterious dark energy. This force is responsible for the accelerated expansion of the universe. As the galaxies continue to drift apart, dark energy will become more and more influential, pushing the universe further into its final stages. In the iron star era, dark matter will serve as the cosmic glue that holds the remaining structures together, while dark energy will work tirelessly to separate them. This tension between the two forces will define the final stages of the universe, creating an atmosphere of slow, inevitable transformation. As dark matter and dark energy continue to shape the cosmos, the transition from an active, star-filled universe to a quiet, iron-rich one will be marked by the slow dispersal of matter. The galaxies will no longer be tightly bound to one another, and the expansion of space itself will continue to stretch the fabric of the universe, making the galaxies and their remnants appear even more distant. The Iron Star era will eventually merge into the final stages of the universe's life. As the galaxies become more isolated and the stars burn out, the universe will enter a period of extreme isolation. But this final stage is not one of sudden chaos. It is the slow, steady march toward entropy. The iron atoms that were created in the cores of dying stars will be the only remnants of the universe's previous life. These atoms will drift through the empty reaches of space, a silent testimony to the cosmic cycle that has played out for billions of years. The black holes, neutron stars, and white dwarfs that remain will not be alone in this empty universe. They will continue to interact with one another, though at a much slower pace. The universe will experience a period of cosmic dark age, where the only activity will be the slow consumption of matter by black holes and the fading of stars into black dwarfs. The transition to this final era will take billions of years. The universe will cool, its radiation fading, until everything settles into a cold, dark state where only the faintest whispers of activity remain. But even in this dark, quiet place, iron will be a constant, an enduring element that symbolizes the cycle of creation, destruction, and rebirth that has shaped the universe. As we move into the final stages of the universe's existence, the heat death looms large on the horizon. This is the point at which the universe reaches thermodynamic equilibrium, when all energy is evenly distributed and no further work can be done. There will be no more stars, no more galaxies, and no more life. Everything will exist in a state of perfect stillness. At this point, the universe will be a place of cold, quiet iron. The remnants of stars will remain, scattered across the void, and the once bright galaxies will have faded into the darkness. Black holes will continue to consume what little matter is left, slowly growing in size. Eventually, even they will fade, their mass turning into pure energy as they evaporate into the vacuum. The universe will end not with a bang, but with a whisper, the slow, inevitable cooling and dispersal of all matter and energy into nothingness. Iron will be the final marker of a universe that was once full of life and light. And so, my friend, the universe will come to its quiet end, leaving behind a cold, empty expanse where iron remains as the only trace of what once was. It is a reminder that even the grandest cycles must come to a close, and that in the end, the universe will return to the stillness from which it was born. In the final days of the universe's cosmic journey, the Iron Star era heralds the inevitable shift into a reality where the universe's activities slow, fade, and eventually grind to a halt. Stars, once alive with the vibrant force of nuclear fusion, have burned through their fuel and collapsed into iron cores, leaving behind lifeless husks scattered across an ever-expanding cosmos. Even as iron remains the primary element marking the death of stars, it also signifies the longevity of a universe that will eventually enter an eternal state of quiet. There will be no more cycles of creation, no more novae or supernovae, no more new stars or galaxies forming. The once bright lights in the sky that painted constellations and illuminated the dark night will have dimmed to nothingness. This iron-laden universe will be marked by the slow, almost imperceptible fading of light. The end stages will be almost impossible for any observer to grasp. The universe will be an immense, cold, dark expanse. Without new stars to fuel cosmic activity, galaxies will drift further apart. They will begin to be dominated by remnants, white dwarfs, black holes, and neutron stars, all composed largely of iron and other elements that signal the final death throes of the cosmic cycle. The remaining remnants will be cold. White dwarfs will cool into black dwarfs, And neutron stars, once fierce and full of potential, will fade to quiet, inert bodies, their once dominant gravitational forces weakened as they too move towards inevitable decay. Even black holes, those cosmic behemoths, will lose the final traces of their once mighty presence as they too eventually evaporate, leaving nothing but the void. But it's not all the end. The iron cores of the collapsed stars will still exist. These final remnants will endure, their density unmatched in the universe. The fate of the last iron cores will be shaped by the invisible forces that continue to push and pull at them. For billions upon billions of years, they will remain static, a testimony to the universe's journey from creation to annihilation. As we continue to observe the dying universe, we are drawn into the idea of a cosmic laboratory, a place where the fundamental laws of physics play out in their purest form. The transition to the iron star era is like watching the final moments of a grand experiment, the conclusion of a cycle that has lasted for trillions of years. This era is not one of sudden violence, but of immense stillness and enduring forces. The fundamental law of entropy will continue its inexorable march toward a state of maximum disorder. But even in this final stage, the universe remains a place of paradoxes. Iron may signal the death of stars, but it also marks their endurance. These iron remnants will persist, eternal in their quiet grandeur. The galaxies themselves, separated by vast stretches of time and space, will remain interconnected by invisible filaments of dark matter. These dark matter structures act as the skeletal framework of the universe, holding galaxies and other remnants together as they slowly drift apart. Dark matter will outlive everything else, its existence never truly understood, but its influence undeniable. It will maintain the skeleton of the universe even as everything else fades into oblivion. Dark energy, the mysterious force accelerating the expansion of the universe, will continue to play its role, pushing galaxies further apart. Over the course of hundreds of billions of years, the universe will continue to expand. And though the galaxies may become isolated from one another, they will still be bound by dark matter, which serves as the invisible glue that holds the cosmic structures in place. This moment, the final days of the universe, is not one of action, but of slow change. The universe is no longer a place of collisions and energy. It is a laboratory, a place where the slow, constant pull of gravity, the steady dissolution of matter, and the ongoing expansion of space continue to unfold. The universe will continue to be shaped by iron, the iron left over from the stars, the iron that represents the culmination of stellar evolution. These iron cores will be the final physical markers of a universe that has cycled through billions of years of birth and death. They will stand as monuments to the universe's story, a story that will never fully fade, but will be preserved in the iron remnants of the cosmos. In this final chapter, iron will be more than just an element. It will become the fabric of the universe's final era. These iron remnants, scattered across the cosmos, will be the last tangible signs of life. They will continue to influence the space around them, albeit in more subtle, slow-moving ways. As we look at these iron-rich remnants, we find ourselves thinking about the longevity of the universe. The iron cores will persist for trillions of years, slowly cooling, until they too will succumb to the heat death of the universe. But even then, iron will endure, It will be the last element standing, the last memory of a time when the universe was alive with stars. The iron stars will not burn with the brilliance of their predecessors, but they will exist in quiet grace. Their final flickers will echo through the endless stretches of space, a reminder of the grand story that unfolded long before the universe settled into its cold, final stillness. Finally, the universe will end not with a violent, chaotic clash, but with a quiet, peaceful surrender. The last stars will burn out, the galaxies will drift apart, and the cosmic web of dark matter will remain as the last structure holding everything together. The legacy of iron will continue, echoing through the cold, dark expanse. And as we look back on the universe's journey, we realize that even in its final moments, the universe's true beauty lies in the way it has cycled through creation, destruction, and rebirth. It is in the iron remnants that this story will live on, forever preserved in the vast silence of space. As the universe approaches its final stage, we are faced with an overwhelming silence. The last stars have burned through their fuel, their iron cores marking the slow, inevitable end of their once radiant existence. These final iron-rich remnants, now scattered across the cosmos, become the tombstones of a once vibrant universe. Over billions of years, iron will become the centerpiece of this cosmic graveyard. The great processes of star formation, the violent births and deaths of stars, will be replaced by the slow decay of matter. The universe will be nothing more than a vast, empty stretch of space, where remnants of dead stars, black holes, and neutron stars float silently through the infinite dark. The process of cooling and entropy will slowly drain the heat from these iron cores. White dwarfs, once the remnants of smaller stars, will cool into black dwarfs. Neutron stars, having exhausted their energy, will grow still. And the black holes, the last true survivors, will eventually dissipate through Hawking radiation, leaving behind no trace of their once mighty existence. This era, known as the Iron Era, is not one of sudden destruction, but of quiet, eternal stillness. The energy that once powered the stars is now long gone, leaving only the echoes of a cosmic dance that unfolded over billions of years. As the universe continues to expand, these final remnants of stars will drift further apart, scattered in the empty void. But there is a beauty in this stillness. The universe will not fade away in a fiery explosion, but will slowly, peacefully fade into the void. It is a slow, graceful surrender, as the last remnants of energy and matter slowly dissipate into the deep, cold expanse. In this final moment, the universe will become a vast, dark sea, where only the faintest traces of light remain. These traces will be the remnants of iron-rich stars and the slow, inevitable cooling of matter. The universe, once alive with energy and motion, will now be a quiet, peaceful place, where time itself seems to stretch and fade into eternity. As the universe approaches its final stage, we are faced with an overwhelming silence. The last stars have burned through their fuel, their iron cores marking the slow, inevitable end of their once radiant existence. These final iron-rich remnants, now scattered across the cosmos, become the tombstones of a once vibrant universe. Over billions of years, iron will become the centerpiece of this cosmic graveyard. The great processes of star formation, the violent births and deaths of stars, will be replaced by the slow decay of matter. The universe will be nothing more than a vast, empty stretch of space, where remnants of dead stars, black holes, and neutron stars float silently through the infinite dark. The process of cooling and entropy will slowly drain the heat from these iron cores. White dwarfs, once the remnants of smaller stars, will cool into black dwarfs. Neutron stars, having exhausted their energy, will grow still. And the black holes, the last true survivors, will eventually dissipate through Hawking radiation, leaving behind no trace of their once mighty existence. This era, known as the Iron Era, is not one of sudden destruction, but of quiet, eternal stillness. The energy that once powered the stars is now long gone, leaving only the echoes of a cosmic dance that unfolded over billions of years. As the universe continues to expand, these final remnants of stars will drift further apart, scattered in the empty void. But there is a beauty in this stillness. The universe will not fade away in a fiery explosion, but will slowly, peacefully fade into the void. It is a slow, graceful surrender, as the last remnants of energy and matter slowly dissipate into the deep, cold expanse. In this final moment, the universe will become a vast, dark sea, where only the faintest traces of light remain. These traces will be the remnants of iron-rich stars and the slow, inevitable cooling of matter. The universe, once alive with energy and motion, will now be a quiet, peaceful place where time itself seems to stretch and fade into eternity. The universe, once a realm of explosive births and violent deaths, has now settled into an unsettling stillness. The stars, those beacons of light that once dotted the sky, are now black dwarfs. These dead remnants of stars have exhausted their fuel, and they no longer burn with the fiery intensity that once lit up the heavens. They are cold, distant, and silent. As black dwarfs, these stars no longer produce any heat or light. Their once blazing cores, having cooled over billions of years, now sit motionless in the vast expanse. Their iron hearts, the final product of nuclear fusion, are a testament to the long journey these stars undertook, from their birth in the dense, primordial clouds of gas, to their fiery deaths, and finally, to this quiet, eternal resting place. Each black dwarf is the end of a star's life cycle, a slow fade into oblivion. But unlike the short-lived brilliance of a supernova, or the violent death of a massive star, the life of a black dwarf stretches out in an endless, calm twilight. There is no grand explosion, no cataclysmic end, only the faintest whisper of heat, slipping away into the void. In this age, there are no new stars. The universe has become a graveyard of sorts, with the black dwarfs marking the final resting places of once vibrant celestial bodies. They exist in a state of cosmic inertia, unaffected by the movements of time or the passing of eons. The galaxies, too, have settled into their final forms. Once filled with the bright flames of creation, now filled with the quiet ashes of dead stars. The journey of a star to become a black dwarf is long and patient, and it tells a story of slow, unrelenting entropy. A star begins its life as a giant ball of hydrogen gas, burning with the energy of fusion. Over time, it consumes its fuel, becoming a red giant, then a white dwarf, and finally, a black dwarf. This final stage is reached when the star has no more energy to emit. The black dwarf is a frozen, silent remnant of what was once a force of nature. And yet, these black dwarfs, though seemingly insignificant, are not completely devoid of interest. They may not be the brilliant, shining stars of their youth, but their mere existence is a testament to the passage of time, a quiet record of the universe's journey from its explosive birth to its gradual decay. As the universe drifts toward its eventual fate, the black dwarfs remain, markers of a time long past, but still part of the fabric of reality. In the quiet, cold spaces between these black dwarfs, we are reminded that the end of one cycle is always the beginning of another. Even though no new stars are born in this dark age, the remnants of the old stars still hold significance. The iron within them, a legacy of their long lives, continues to influence the universe in subtle ways. From this iron, new elements were once forged, spreading through space to eventually form the planets, moons, and life we know today. The Iron Era, despite its stillness, has shaped the very structure of the universe. Every black dwarf, every piece of iron in the cosmos, is a small part of a larger, ongoing process. And though the stars may no longer burn, their legacy remains, etched into the fabric of space and time. As we peer into the cold, dark stretches of the universe, we find ourselves pondering the long-term future of the black dwarfs. Will they eventually fade into nothingness? Will they be consumed by the slow, inevitable march of entropy? Or will some unknown process one day stir them from their eternal slumber, perhaps reigniting a spark that has lain dormant for eons? Only time will tell. But for now, the universe remains still. The black dwarfs, the silent guardians of the cosmos, continue to drift through the void, their story one of patience and quiet endurance. In their dark, frozen hearts, they carry the memory of the stars that once were, and the echo of a universe that will eventually find its rest. The universe has become a place of stillness. The once vibrant stars are now black dwarfs, their iron cores having cooled over billions of years, no longer emitting heat or light. These remnants mark the end of stellar life cycles, moving through the cosmos in a state of cosmic inertia. Black dwarfs exist in silence, their faint glow a final reminder of the intense nuclear processes they once powered. As the galaxies, too, settle into their final forms, the universe drifts toward entropy. The black dwarfs, though seemingly inactive, hold within them the history of the universe, marking a quiet transition from creation to decay, a long and patient journey through the endless depths of time. The iron within them, once part of the furnace of creation, continues to influence the cosmos in subtle ways, leaving behind a legacy of the stars that were. The universe is shifting into a new phase, where the once immense cosmic furnaces that birthed the elements are no longer active. The stars, those brilliant beacons that once filled the night sky, are slowly fading into a quiet, cold eternity. As these stars reach the end of their life cycles, they become black dwarfs, their iron cores having cooled over billions of years. These black dwarfs, the remnants of stars that once burned brightly, are now in a state of cosmic dormancy. No longer do they shine with the heat of nuclear fusion. Their light has dimmed, and their energy has been slowly dissipating into the vastness of space. Iron, the very element that marks the end of their fiery existence, is now the defining feature of these celestial bodies. In this era, the universe has reached a kind of stillness that was once unimaginable. The process of stellar birth, where stars form from swirling gas and dust, has largely ceased. The star-forming regions, once teeming with the energy of creation, have become barren, their gases either swept away by cosmic winds or consumed by dying stars. Iron, the byproduct of nuclear fusion in massive stars, is now the dominant element in the universe. Stars that once burned bright with hydrogen and helium are now a memory, replaced by the cold, metallic remnants of their iron-rich cores. As these black dwarfs drift through the vastness of space, they represent the final stage in the life cycle of stars. The light they once emitted has long since faded, leaving behind only a faint glow, a lingering memory of their former brilliance. These remnants are scattered across the universe, silent and motionless, waiting for the inevitable passage of time to wear them down even further. They are the final echoes of the great cosmic processes that once forged the elements and sparked the birth of galaxies, stars, and planets. In the absence of these once vibrant stars, the universe is now a quiet, iron-clad expanse where the dance of creation has given way to the slow, inevitable march of entropy. In this era, known as the Iron Star Era, the universe is a place where entropy reigns supreme. The black dwarfs, now the remnants of what were once the brightest stars, are locked in a slow, cold death spiral. Their iron cores are the last vestiges of the energy they once radiated. These cosmic remnants drift through space, indifferent to the passage of time. Their presence serves as a reminder of the universe's journey toward entropy, where everything eventually fades into a cold, ironclad silence. The universe, once a dynamic place of creation and destruction, is now a place of stillness and quiet decay. The iron within these stars, once the product of fiery fusion in their cores, is now the dominant force in the cosmos, marking the final chapter of the universe's long, slow decline into a state of cosmic equilibrium. As we continue to observe this new era, the universe's transformation becomes more evident. The stars that once shone so brightly, igniting the cosmos with their intense radiation, are now a distant memory. The galaxies that once teemed with life, with vibrant nebulae giving birth to new stars, are now dominated by the cold, lifeless remnants of dead stars. The gas clouds that once swirled with the potential of new stellar births have either dissipated or been swept away by the expanding void. The process of star formation, which was once a dynamic, chaotic force, has slowed to a halt. The gas necessary to fuel new stars is no longer abundant, and as the old stars burn out and fade away, the universe enters a period of quiet stagnation. In this Iron Star era, the universe is a place of transition. The once thriving star-forming regions are now quiet, with only the faintest traces of their former glory. The iron-rich remnants of dying stars, including the black dwarfs and the white dwarfs, remain as a testament to the long journey that the universe has undertaken. These remnants are no longer capable of creating new life, but they serve as a quiet reminder of the cosmic forces that shaped the universe. The iron cores that make up these stars are the result of countless years of fusion, where hydrogen and helium were fused into heavier elements. These elements, once essential to the formation of new stars, are now the remnants of a bygone era. The universe is now a place where the forces of gravity and time are the dominant players. The once powerful forces that fueled the birth of stars have now given way to the slow, inevitable pull of gravity. The iron cores of the black dwarfs, now cold and lifeless, are slowly being pulled toward one another by the inexorable force of gravity. Over billions of years, these remnants will drift through space, colliding with other objects and slowly merging into larger bodies. The universe, once a place of dynamic, ever-changing motion, is now a place of stillness, where the remnants of once vibrant stars drift slowly through an expanding, ever-cooling void. However, the passage of time is not without its significance. The universe may be entering a phase of stagnation, but it is still evolving. The iron-rich remnants of the old stars will continue to interact, slowly merging into larger bodies. The gravitational forces between these remnants will continue to shape the future of the universe, even in this quiet era. Eventually, the accumulated mass of these objects may lead to the formation of new cosmic structures, albeit on a far longer timescale than anything we can currently comprehend. The iron star era, while quiet, is not without its beauty. The remnants of the stars, though no longer shining with the intensity they once did, still possess a quiet, subtle glow. These objects, though cold and lifeless, are part of a larger cosmic dance. The iron cores of black dwarfs and white dwarfs will continue to evolve, slowly changing as the forces of gravity pull them together and cause them to merge into larger bodies. The universe, in its quiet decline, continues to evolve, slowly and imperceptibly, marking the end of one phase and the beginning of another. As we continue our journey through the Iron Star era, we see the slow yet inevitable transformation of the universe into a cold, dark expanse. The age of vibrant stars, nebulae, and galactic collisions has passed, leaving behind the stark remnants of a universe that has reached the end of its life cycle. The stars that once illuminated the cosmos are now nothing more than faint, dying embers, white dwarfs, black dwarfs, and neutron stars, drifting alone in the ever-expanding void. These remnants of stellar evolution hold the last vestiges of the universe's energy, though they now only faintly radiate in the cold, dark space. The void between these dying stars continues to grow, as the gas clouds that once fueled new generations of stars have either been dispersed or consumed. No new stars are born in the depths of this cosmic wasteland. Instead, the universe is filled with the quiet aftermath of its stellar activity. The galaxies, once lively with the births and deaths of stars, are now quiet and stagnant. The great cosmic dance has slowed, and the universe's expansion has further stretched out to already vast distances between these ancient stellar remnants. Yet, even in this stillness, there is a certain grandeur. The remnants of stars that have reached the Iron Star era still possess remnants of their former glory. These remnants, made of heavier elements like iron, have been forged in the hearts of dying stars over billions of years. The iron-rich cores of white dwarfs and black dwarfs now sit at the centers of dead star systems, silent and still, holding on to their final energy as they slowly cool. The iron elements, so crucial for the formation of life in earlier eras, are now locked away in these ancient remnants. Remnants that may eventually become the seeds of new cosmic structures over unimaginably long timescales. The slowing of star formation also means that the once vibrant cosmic interactions have ceased. The once dominant forces of gravity, stellar radiation, and cosmic winds are now replaced by the cold, inevitable march of time. As galaxies continue to drift apart, there are no more starbursts, no more supernovae to light up the sky. The vast regions of space that were once filled with energetic phenomena are now quiet, empty, and dark. It is a universe that is at peace with itself, though this peace comes at the cost of motion, of creation. However, As the universe's energy continues to dissipate, the process of entropy ensures that no system will remain entirely still. The remnants of dead stars will continue to interact, albeit at a much slower pace. Over eons, the black dwarfs, once thought to be the final stage of stellar evolution, may collide or merge, releasing the last traces of energy they possess. These interactions will be rare, occurring over billions of years, but when they do happen, they will release a final burst of energy that may light up the surrounding void, offering a brief flash of life in a universe slowly fading into darkness. This slow, inevitable decline may seem like the end of the universe's story, but it is in fact the beginning of a new phase, one that exists beyond our current comprehension of time and energy. The iron remnants of stars, the ghostly remnants of their former selves, will drift through space, bound by the forces of gravity, until they either merge into larger bodies or eventually fade into nothingness. The universe will continue to cool and expand, its once vibrant energy now dissipated into the vastness of the void. In this iron star era, the universe's future is uncertain. Some speculate that the remnants of these dead stars will one day create a new kind of cosmic structure, perhaps a final burst of activity that will mark the end of this slow phase. But for now, the universe exists in a state of suspended animation, where even the most dramatic events are mere echoes of what once was. The stars are gone, and the forces that shape them have quieted. What remains is a vast expanse of iron, remnants of what was, slowly cooling in the cold, empty space. This is the final act of a universe that once teemed with life, now fading into the distant silence of eternity.